Chi-square analysis. Chi-square test. The chi-square test is a commonly used statistical test for testing hypotheses in health and social sciences research. This test is suitable to determine the association between two categorical variables, whether the data are from cross-sectional, case control, or cohort studies. Data use dataset 3. Assumptions. Suppose you have collected data on gender, sex, and diabetes from a group of individuals selected randomly from a population. You are interested to know if there is an association between gender and diabetes. In this scenario, chi-square test is the appropriate test for testing the hypothesis. Hypothesis H0. There is no association between gender and diabetes. It can also be stated as gender and diabetes are independent. HA. There is an association between gender and diabetes, or gender and diabetes are not independent. Commands: Analyze next, Descriptive statistics, next crosstabs, next select gender, and push it into the rows Iwantro box, next select diabetes, for the columns box, next statistics, next select chi-square, and risk, next, continue next cells, next select raw, and column, under percentages, next continue, next OK. Commands. Output. Interpretation. The 2x2 table of sex and diabetes with row percent within sex of respondents and column percent within have diabetes mellitus percentages. The question is, which percentage should you report? It depends on the situation, study design, and what do you want to report. For the data of a cross-sectional study, it may provide better information to the readers if row percentages are reported. In this situation, the row percentages would indicate the prevalence of the condition. For example, one can understand from the table that the prevalence of diabetes among males is 32.5% and that of the females is 15.0% when row percentages are used. However, column percentages can also be reported for the cross-sectional data. Most of the publications use column percentages. If column percentage is used, the meaning would be different. In this example, it means that among those who have diabetes, 55.6% are male compared to 31.5% who do not have diabetes. If the data are from a case control study, you must report the column percentages. You cannot use row percentages for case control studies. On the other hand, for the data of a cohort study, one should report the row percentages. In this case, it would indicate the incidence of the disease among males and females. Interpretation. The next table presents Pearson chi-square test results, including the degree of freedom, DF, and p-value, A-sig. The table also shows other test results, such as continuity correction and Fisher's exact test. Before we look at the chi-square test results, it is important to check if there is any cell in the 2x2 table with expected value less than 5. This information is given at the bottom of the table at AA, as 0 cells, 0%, have expected count less than 5 inches. For the use of the chi-square test, it is desirable to have no cell in a 2x2 table with expected count less than 5. If this is not fulfilled, we have to use the Fisher's exact test p-value to interpret the result. In fact, to use the chi-square test, no more than 20% cells should have expected frequency less than 5. You can get the expected frequencies for all the cells if you select Expected under Count in Cell option during analysis. For the chi-square test, consider the Pearson chi-square value, since there is no cell with expected value less than 5. In our example, chi-square value is 8.799, and the p-value is 0.003. Since the p-value is less than 0.05, there is an association between gender and diabetes. It can, therefore, be concluded that the prevalence of diabetes among males is significantly higher than the females, which is statistically significant at 95% confidence level, p equals 0.003. Interpretation. The final table shows the OR, 2.716, and its 95% CI, 1.385 to 5.327. Use the OR if the data are from a case control study. Odds ratio is also sometimes used for cross-sectional data. The table also provided the RR, 2.159, and its 95% CI, 1.288 to 3.620. Take the RR and 95% CI for diabetes. Factor: yes. Use RR if the data are from a cohort study. Note that both the OR and RR is statistically significant, as they do not include one in the 95% CI. Odds ratio 2.71 indicates that males are 2.7 times more likely to have diabetes compared to the females. On the other hand, RR 2.15 indicates that the risk of having diabetes is 2.1 times higher in males compared to females. Thank you.